And specifically, we'll discuss safe hardware accelerators utilization in AUTOSAR adaptive platform. Here's a short agenda of what we'll talk about today. Some words about working group organization. The concept was initiated by BMW, Intellas, and Kronos Group, and it's under active development right now. I would like to thank these companies for their great technical support and significant contribution to the project. Also, it's known that great moments are born from great opportunities, and I would like to thank AUTOSAR Consortium and Intellas management team for giving me the opportunity to be here today with you. Let me share our motivation or why we came to the conclusion that the concept is really on time. I am a pure automotive guy, and I was working for different worldwide known manufacturers, and what is common for all of them, they all are eager to achieve the highest performance. They want to have a quick system reaction to user actions, thus gaining better user experience and satisfaction level. They want to have a faster system response when executing heavy algorithms. But heavy algorithms always require powerful hardware, which already exists. And there are smart systems like we have seen in many previous presentations, like ADAS or autonomous driving, which exactly executing heavy algorithms. Unfortunately, in many cases, those systems are still using general purpose CPU. And the good news is many of the same algorithms can be executed more effectively and much faster on the hardware accelerators. At the moment, manufacturers are trying to implement their own solution, and our intention to create a highly effective standardized approach in AUTOSAR adaptive. So manufacturers can save their time, efforts, and money. So AUTOSAR adaptive is already a great system, and we would like to make it a bit more attractive. Let me say some words about our objectives in the concept. And the first objective, as I already said, we would like to create standardized approach for HWA utilization. And some word about this abbreviation, HWA. It was initially introduced by Texas Instruments, semiconductor manufacturer company, and it means exactly hardware accelerator. The next objective is application performance enhancement. We would like to enable parallel programming along with hardware accelerators utilization. And the next one is also about application, where we would like to decrease application development complexity by provision high-level C++ based API. And why C++? Because it's the main language in AUTOSAR adaptive platform. So application developer doesn't need to know anything else except modern C++. And he is ready to go for parallel programming, and that's it. And the next objective is flexibility. So AUTOSAR adaptive vendor will be able to implement our API by choosing any of the existing backends on the market. And those backends can have different hardware support set. The next is probably the most important objective within our concept is safety. And we would like to make hardware accelerators utilization safe as much as possible. Of course, we understand that API definition, even safe API definition, will not make the entire stack safe. And I will give a bit more details about safety approach in the next slide. And the last objective here is extensibility. So we are not restricting our concept right now with safe hardware accelerators utilization, and it can be extensible in many different ways, which I also will mention a bit later. So let's have a short overview to the existing parallel programming frameworks. I think most of you or many of you knows of these names: OpenMP, NVIDIA, CUDA, OpenCL, SYCL. It's not a comprehensive set. It's just a short set. All these frameworks, they have their own benefits and drawbacks and restrictions, but what is common for all of them? There is no safety-critical qualified version and especially standardized version for automotive. I have to admit that the work is ongoing. Many of these products have proposals for improvement, but as I already said, no safety qualified standardized version for automotive. So moving forward, let me introduce this diagram, a well-known diagram, how we plan actually to realize and integrate our concept to the AUTOSAR adaptive architecture. This is well-known picture, but here's something, where's the laser? Something new here. And here the high performance box here, it's a new functional cluster introduced by our concept. And what is worth to mention here, that this cluster won't be restricted, won't be limited by only usage for Safe Hardware Accelerator API. It can be extended in the future by different APIs, for example, for augmented reality or computer vision or artificial intelligence. So our Safe HWA API is just a first part of it. Let's have a look to the proposed solution architecture. There's different boxes in different colors, and we are focused within our concept on this part and this part. So we define Safe HWA API along with AUTOSAR adaptive specifications and recommendations for the vendor how to implement it. In the future, adaptive application will use defined APIs or header files and specification for their computation needs. From the right side, in a pink box, we can see a box about adaptive vendor implementation. So the vendor will use all those specifications to implement the API. And under the hood, on the lower part, you can see that the implementation will have to use some hardware accelerator framework or libraries to interact with hardware accelerators. And at the moment, we decided to go with SYCL 2020 standard API provided by Kronos Group. And why we decided to go with SYCL? Because SYCL 2020 allows us to implement most of the features required by our API. What is missing in the SYCL? It's hardware monitoring, and that's exactly why we specified additional box here, that API monitoring part can be and should be implemented using by different tools. Tools can be, for example, native tools in AUTOSAR adaptive or some other tools more suitable for your backend. For example, if the vendor has NVIDIA hardware, of course, it will be more suitable and more effective to implement hardware monitoring using NVIDIA provided libraries, because they can provide much more useful information which is needed for further handling. And additional benefits of SYCL standard that many implementations of that standard API exist on the market. So we just specified here 3 of them, and there are more than 20 at the moment. And you can see here, so they're implemented by different well-known companies like DPC++, by Intel, Compute CPP, by CodePlay, HipSYCL by Heidelberg University. There's another implementation from AMD, and what is good that all of them are following the same API, but can have different hardware support. So some words about planned features within our concept. The first feature is a single source compilation model. What that means? That application developer will need just to write down C++ code in one file, so-called translation unit. And the compiler will automatically recognize the portion of the code intended to be executed on the host. And the host, in terms of a heterogeneous programming, means that the code will be executed on the CPU. And the next, the automated method of recognition will also follow the next portion of the code that intended to be executed on the device. And device, in terms of heterogeneous programming, means exactly hardware accelerator. Moving to the next feature, we would like keep possibility to use vendor own compiler. For example, if the vendor has a great safety qualified compiler, he still can use it for compilation of kernel functions. Moving to the next feature is about determinism. So we want to provide possibility for explicit queuing, ordering, and execution state of the tasks within one AUTOSAR adaptive application. The next feature is more restrictive feature, task execution within one ECU. So at the moment we decided to restrict it to avoid possible issues with tasks synchronization and result of task execution between different ECUs, because it's really quite hard. We have, by the way, it's in the backlog to consider the possibility to extend the concept in the future, but at the moment we decided to restrict it with the feature. The next feature is configurable hardware resources. Someone may say that this feature already exists in AUTOSAR Adaptive, and that's actually true, but we want to extend this feature by hardware accelerators, configurable resources, which is absent at the moment. Moving to the next one, it's hardware accelerator state monitoring. So with our API, along with implementation, we would like to have possibility to get information about hardware at any moment of time, that we will know that a hardware is working properly or something goes wrong. And one more restrictive feature, the application which will be using our API will not be allowed to communicate to the hardware accelerator directly. So all the interaction with the hardware accelerator will be done through our API. And the last but not least feature is the control of unsafe calls to the hardware accelerator. And we are planning to base this feature on a hardware configuration, which can be achieved using different AUTOSAR adaptive manifests. The key aspects of our concept is flexibility. And just for the maybe convenience, we have divided it into 4 parts. The first part is integration flexibility. So any compatible hardware accelerator library is supported. So we're not restricting by usage only SYCL libraries. The next one is implementation flexibility. So for example, as I mentioned previously, hardware monitoring can be implemented by using not only AUTOSAR adaptive native tools or native libraries, but only including and utilization of more suitable libraries depending on the hardware set. And the next flexibility is the choice flexibility. So the very wide range of hardware supported can be chosen, for example, by different SYCL implementations. And as I already said, there's almost 30 different SYCL implementations on the market. Some of them are proprietary, some of them open source, which can be used for free. And moving to the last flexibility part is portability. So our intention is to keep portability of the application code between different AUTOSAR adaptive platforms where the API is implemented. So application developer will have possibility just to get the code of his application and move it, transfer to the different AUTOSAR adaptive platform with no changes to minimal changes. And the changes will be needed only in case if the hardware is different on the other platform. And now it's time to discuss safety in a bit more details. In order to understand how to achieve safety on the entire stack, we need to understand involved parts to the safety. And the first part here is the API. Can you? Okay, thanks. The first part is the API, where we are focusing exactly within our concept along with the specifications. But a safe API is not enough to achieve the safety in the entire stack. The vendor should implement our API according to safety instructions, and those both parts will be safe. But under the hood, vendor implementation will use some hardware accelerator framework, and here the place where we can see the huge gap. At the moment, even SYCL 2020 is not ready to be used in a safety critical environment. But what is worth to mention here that Kronos Group is actively developing SYCL safety critical version, and we are the part of SYCL safety critical working group, so we are on track with its development, and our API will be fully compatible with SQL Safety Critical. And the last part is about hardware. The last part, which should be also safe, is the hardware driver. It should be safety qualified, and the hardware itself should be built according to, for example, in automotive, according to ISO 26262 standard. By the way, we know that such hardware already exists from different manufacturers. But how to achieve safety for this proposed solution? So here we can see some set of rules or actions we need to perform to achieve at least minimal level of safety. We plan to use only safe AUTOSAR adaptive defined data types. We plan to make our API exception free. We extend our API with the hardware availability monitoring and hardware task execution status, along with hardware tasks explicit execution ordering. As I already mentioned before, we plan to extend hardware configuration for hardware accelerators. Additional feature here, additional action here that we would like to have and to provide control of unsafe library calls. And the last part here is error detection. Is probably the most complicated one. We have divided it into 4 parts here. So preventive error handling based on hardware resources configuration. The next one is synchronous errors, that host code errors. That means the errors can appear in the code executed by the CPU. The next part is asynchronous errors, which can appear in SQL runtime. And SQL runtime is the glue which connecting the host code with the device code. And the last part is probably the most complex ones, unfortunately, device errors. So we cannot get information about device errors directly with the SQL or directly from the device. If the device has failure, it can be unresponsive and we cannot get any information from it. So we need to utilize and to use separate hardware monitoring. And this is exactly what is needed to perform some corrective measures or to roll back to the safe state. And let's have a look to the safety structure in AUTOSAR Adaptive Platform. There are already great tools or maybe great functional cluster like a platform health management, state management, and execution management, which are mainly responsible for safety in AUTOSAR Adaptive Platform. And we plan to utilize them as well. So you can see on this kind of flower that we have those functional cluster, and when we have safe hardware, safe libraries, and safe API, this is the vision of full safety structure. And moving to the next slide, here I would like to show how, just high level with no deeper details, but I would like to show how AUTOSAR adaptive application will interact, will utilize our API, and at the same time will be using existing tools in AUTOSAR adaptive platform related to the safety. So AUTOSAR adaptive platform, where's the laser? Just a second. AUTOSAR adaptive application will use our API to request information about task execution or hardware availability from the hardware itself. And when it receives this information, it will report this information to the platform health management, for example, by using predefined checkpoints. So platform health management will know at any moment of time that application is working properly or something goes wrong. And in case of failure of application, platform health management will forward this information to the state management. State management in its turn will change application state and inform execution management. And execution manager in its turn will decide what to do with the application. Should it be stopped or should it be restarted? And so on. That will be responsibility of execution management. And moving closer to the conclusion, I would like to say some words about further plans of our concept. First of all, we would like to move from SQL 2020, which is unsafe, to the SQL safety critical version when it will be ready. The next plan is extend safety features of our API For example, as I said, now it's not possible to execute different tasks on different ECUs, and here's in our backlog. So we would like to consider the possibility to synchronize. So in that case, we will achieve even more performance. Of course, it's known that it's always trade-off. When you're increasing performance, you're decreasing safety. And we always need to find the golden middle here. The next plan is to extend high-performance computing functional cluster with new functionality. So we can add needed API, which will be demanded on the market. And the last plan here is to integrate ongoing AUTOSAR adaptive platform concept related to the hardware monitoring. It's now also under active development, and we have communicated to the group, to the Huawei, who is developing that concept, and we can see a great perspective here to utilize it in our concept. I would like to thank you very much for your interest, and if you feel that you have enough knowledge for advices, I ask you to join us. We'll be happy to work with you, and yeah, thank you very much for your